Good morning, students. Today we can continue the complex numbers topic problems. Now, 31st problem. Here given argument of z less than 0 means argument of z is negative value. Required argument of minus z minus argument of z. Now, argument of minus z. Here argument of z less than 0, negative value. Therefore, argument of minus z. First argument of minus z equals to pi plus theta, where theta is, let argument of z equals to theta. Z equals to theta. Now, argument of minus z equals to pi plus theta, because here theta less than 0 given argument. If suppose only argument of z is theta, if it is positive, pi minus theta. Therefore, here required value argument of minus z, required argument of minus z minus argument of z. Now, argument of minus z equals to pi plus theta minus argument of z is theta. Minus theta plus theta get cancel, pi equals to pi. Now, option is first option. Next, if here given condition mod of z1 plus z2 equals to mod of z1 minus z2, then the difference between arguments of z1 and z2 means required argument of z1 minus argument of z2, Now, first here consider z1 equals to r1 of cos theta 1 plus I sin theta 1, polar form. Means here r1 nothing but modulus of z1, theta 1 is argument of z1. Next, z2 equals to consider r2 into cos theta 1, theta 2 take it, plus I sin theta 2, Okay. Now, z1 plus z2 equals to r1 cos theta 1 plus r2 cos theta 2 plus r1 I sin theta 1, r2 I sin theta 2. Now, I take common, we get r1 sin theta 1 plus r2 sin theta 2. Now, required mod of z1 plus z2. Mod of z1 plus z2 equals to square root of real part square plus imaginary part square. r1 cos theta 1 plus r2 cos theta 2 whole square plus r1 sin theta 1 plus r2 sin theta 2 whole square. Now, that equals to square root of r1 cos theta, r1 square cos theta 1 square plus r2 square cos square theta 2 plus 2 r1 r2 cos theta 1 cos theta 2 plus similarly r1 square sin square theta 1 plus r2 square sin square theta 2 plus 2 r1 r2 2 r1 r2 sin theta 1 sin theta 2 sin theta 2. Now here r1 square cos square theta 1 plus r1 square sin square theta 1, that equals to we get square root of r1 square. Similarly r2 square cos square theta 2 plus r2 square sin square theta 2. Now r2 square take common, cos square theta 2 plus sin square theta 2 1 r2 square. Next in remaining two terms 2 r1 r2 take common, we get cos theta 1 cos theta 2 plus sin theta 1 sin theta 2, that is nothing but cos of theta 1 minus theta 2, cos of theta 1 minus theta 2. Similarly we get z1 minus z2, mod of z1 minus z2 equals to square root of r1 square plus r2 square minus 2 r1 r2 cos of theta 1 minus theta 2, cos of theta 1 minus theta 2 we get. Okay. Now here mod of z1 plus z2 equals to mod of z1 minus z2 given. Now squaring on both sides, mod of z1 plus z2 whole square equals to mod of z1 minus z2 whole square. But mod of z1 plus z2 equals to this value mod of z1 minus z2. Now both are equal, that equals to r1 square plus r2 square plus 2 r1 r2 cos of theta 1 minus theta 2 equals to mod of z1 minus z2 whole square equals to r1 square plus r2 square minus 2 r1 r2 cos of theta 1 minus theta 2. Now r1 square cancel, r2 square cancel, complete take left side, we get 4 r1 r2 cos of theta 1 minus theta 2 equals to 0, complete take left side. Now it is also a complex number, here its modulus equals to 4 r1 r2 and amplitude equals to theta 1 minus theta 2. Now theta 1 minus theta 2 equals to 90, because cos theta equals to 0, theta equals to 90 degrees. Now theta 1 nothing but argument of z1 minus theta 2 argument of z2, that equals to 90 degrees. Pi by 2 is the answer. Now answer pi by 2. Then option B is correct. Second option. Next, z equals to, here given z equals to 1 plus I root 3 whole square by 4i into 1 minus I root 3. Then mod z, modulus of z and argument of z both are required. Now here given z equals to given 1 plus I root 3 whole square, a plus b whole square, expand 1 plus I square into 3 minus plus 2i root 3 by denominator 4i of 1 minus I root 3, that equals to, here I square equals to minus 1, 1 minus 3 minus 2 plus 2i root 3 by 4i of 1 minus root 3 I root 3. In numerator minus 2 take common, minus 2 of 1 minus I root 3 by 4i of 1 minus I root 3. Now 1 minus